Hello. Today we're going to talk about solving logarithmic equations. We're only going to do four problems. Kind of quick. There's not really much to it. We'll just start out. So kind of as a review, when we see an equation, we're going to see equal signs, but really what we're doing is we're going to apply logarithmic properties. So hopefully you notice that on this first question, there's a plus sign in between, so we will use product property. And on this other side, there's a minus sign. So when we combine the two logs, we'll use quotient property. What's different about what we did from last class, though, is that both of these are going to be equal to something. So we will see what changes. Well, first, I do notice that on the left side of the equation, there's plus sign, so I will use product property. I will multiply 4x by 5. And it equals log base 2 of 80. Well, 4x times 5 is 20x. Was log base 2 of 80. Now, with an equal sign just means you want both sides to be exactly the same when you simplify them. Now, I notice when I'm looking at these two that they both have a log with a 2. So if I really want them to be equal, I want the arguments to be equal. I want to see what x is going to be so that 20 times x equals 80. I want these to be the same. So let's solve for x. Let me divide both sides by 20 since it's 20 times x. And that will give me x equals 4. And that's it. So in this first type of scenario that we're looking at for solving logarithmic equations, I use log properties to combine. Then if I see that both sides have a log, this is how I will proceed. Now let's look at another one. So first I see on this side, I have two logs subtracting, so I want to use quotient property to combine. So I will have log base 5 of 7x divided by 3 is equal to log base 5 of 21. Now yet again, I find that both sides have a log with the same base. So that means I want the arguments to be equal. I want to set 7x over 3 equal to 21 and see what x has to be. Now, first, I want to get rid of this divided by 3. So I will multiply both sides by 3. That will get rid of the 3 in the bottom, leaving me with 7x is equal to 21 times 3 is 63. You could always use a calculator for that. Then finally, to get the x alone, I want to divide by this 7. And then that would leave me with x equals 63 divided by 7, which is 9. So our first scenario is that when we finish simplifying, we will have a log with the same base on both sides of the equation. Now, we will have another type of problem, and that is what we will see here. So notice that, okay, we have two logs with the same base. They're adding, so I'm going to use product property. Now, 7x times 4 is 28x, so we'll simplify that. Equals 4. Now, what I don't have here is two logs with the same base on both sides of the equal sign. So, how do I get x alone? Well, I have to get rid of the log. But the way I get rid of log is doing the opposite of log, which is an exponential. So we're going to bring back our exponential to logarithmic, going back and forth formula. that we had a few lessons ago. We are going to use it for this scenario when I have a log on one side but not the other side. So here, if I'm trying to rewrite this log that we have, log base 6 of 28x equals 4, if I'm trying to rewrite that log equation as an exponential, I want to start out with my base, which is that little number on the bottom, 6. Then my exponent is going to be what's on the other side of the equal sign, which is my 4. And then this is going to equal my argument, which is what's inside the parentheses of the log, 28x. Now, 6 to the 4 is just a number. I just need to get x alone. So I see that there's the 28 multiplying by x. So I'm going to divide by 28. Now, you can use Desmos to figure out what this is. Okay, and when I do, let's see. When I do, I will probably, I think it's a decimal. 6 to the 4 divided by 28 it is. So we can use the fraction button to just make it a simplified fraction. And that is my answer. So we're going to look at one more example. But this is pretty much the most complicated we're going to get right now. All right, so we'll just do one of these. I think most people wanted to see the second one. Most people thought the second one looked more complicated. So we're going to look at this one. And I see more than one property happening. I see power property and I see quotient property happening because of the 2 in front of that log and then the minus in between the 2 logs. As usual, we'll start out with power property. So I'll put that 2 on top of that log. Okay, hopefully we will plug 1 squared into a calculator and find that 1 squared is 1. So this is really just then we will apply our quotient property and divide 7x by 1. And hopefully we realize that 7x divided by 1 is just 7x. And so here we are in a similar situation as our last problem where we have a log, base 2, on one side, and then on the other side of the equal sign, we do not see a log. So in order to get x alone, I have to use my exponential to logarithmic formula. E equals log b a equals x. So I'm going to start out with my base. My base here is 2. My exponent also happens to be 2. Just a coincidence. And then it equals 7x. To get rid of the 7, since it's multiplying, I will divide. And then we can use our calculator to see what 2 squared divided by 7 is. So we'll do that. 2 squared divided by 7. It is just 4 over 7. So my answer is 4 over 7. And that's it. So hopefully that helps if you missed, and let me know if you have any other questions.